New Zealand carbon emissions must be cut to meet national commitments to climate change, as the energy sector is only responsible for around 10% of total greenhouse gas emissions. Targets are based around electrification of industrial and transport sectors. In order to enable this, the electricity sector will undergo extreme pressures in the coming years, and combined with the goal of 100% renewable electricity by 2035, poses an interesting problem. An increase in renewable energy generation from wind and solar increases the grid reliance of variable energy sources. To enable this, there is a need for storage alternatives that can provide a reliable baseload and have the ability to be tapped into in times of high electricity demand. There is currently the option of Lake Onslow being developed in the South Island. However, there is no detailed assessment in the North Island, closer to high demand regions. In response to this problem, the research project aims to select suitable pumped hydro energy storage sites in the North Island, and develop conceptual scheme designs for these locations. Develop a sustainable economic assessment framework to guide decision makers in future renewable energy storage investments, and to evaluate the suitability of the pumped hydro energy storage schemes using the sustainable economic assessment. Pumped hydro energy storage is a very applicable option in the context of New Zealand. The country is already familiar with the technology and infrastructure, having an energy makeup of around 50 to 60% hydropower. This will benefit from having an upstream storage system that will also act as a method to shore up supply. Pumped hydro is a renewable energy storage option which aligns with New Zealand's targets for 2035. Pumped hydro works through storing water in an upper reservoir, which can be released to power turbines. The ideal operation for a pumped hydro scheme is to pump water up during times of low electricity demand, off-peak hours. This can then be released during peak hours when demand is high. It can also be stored long-term as an energy reserve for dry years.
Pumped hydro energy storage are most typically used an existing lake as a lower reservoir. To be feasible and cost-effective, it must be possible for an upper reservoir to be constructed nearby at a significantly higher elevation. Suitable sites are typically high-altitude basins that can be impounded by a single dam. 3 locations previously identified in literature were found to be the most suitable. These are at Lake Whakamaru, the Naruroro Valley, and Lake Moawhongo. The second upper reservoir location at Lake Moawhongo was also identified. 3D elevation models of the reservoirs were developed using GIS software. Each model was optimized to have a dam height and upper reservoir operating range that balance cost, energy storage, and environmental impacts. Optimal dam heights were all found to be between 50 and 70 metres. The Naruroro scheme had the greatest energy storage potential, with 217.8 gigawatt hours of operational storage, compared with the smallest Moawhongo 2 scheme with only 9.4 gigawatt hours of storage.
The sustainability framework is intended for application prior to the design stage. Therefore, a low-level, fast design process is needed to provide initial values for materials needed in the sustainability and cost assessments. The practical dam cross-section has been derived from an amalgamation of literature to provide an iterative formula for designing a dam cross-section based off the relative height. Therefore, based off the height of a dam and with some manual changes to the heel length, a dam cross-section can be developed.
Scheme costs were estimated using the design data and correlations between scheme size, site geology, and construction costs published in literature. Costs for the Moawhongo and Whakamaru schemes were all approximately $1.2 billion, whilst the Naruroro scheme was considerably more expensive at $3 billion to develop. However, when costs by lifetime electricity generation and storage capacity are considered, the Naruroro scheme becomes more cost-effective due to its large size. One criticism of pumped hydro energy storage is that there can be several environmental impacts that are difficult to reconcile with the cost and benefits of the energy storage. To address this, a new sustainable economic assessment framework specific to electricity generation has been developed. This is intended to guide decision makers in the preliminary phase of a project as to what generation alternative is most suitable and warrants further investment. The framework matches the decision maker's sustainability goals with scheme-specific sustainability data to quantitatively and qualitatively evaluate the environmental, social, and economic sustainability of each scheme relative to each other. A range of sustainability indicator data, including cost and electricity generation, is processed using the PLS VIP multivariate analysis method and outputs an aggregate index sustainability score. A lower aggregate index score indicates better sustainability. When applying this framework to the proposed pumped hydro schemes, it was found that Moafongo 1 consistently performed strongly in environmental, social, and economic metrics, and can be regarded as the most suitable of the 4 sites for development. The large Naruroro scheme has a large sustainability and cost footprint. However, if the need for dry air storage is prioritised, it is a considerably better option. It is intended that the framework can be used in the future to compare other energy storage alternatives to pumped hydro and identify the ideal solution to help New Zealand meet its electricity needs. Thank you very much.